Hello. In this lesson, we're going to take a look at percent composition. Now, percent composition is the characterization of a chemical compound and its percentage of mass of each element within that chemical compound. And it's defined by this equation here. The mass percentage of each element is equal to the mass of that individual element within the compound divided by the total mass of the compound. The sum of all the mass percentages of all the elements in the compound must be equal to 100. Now, this gives us a clue as to its molecular formula, and also we can do this in reverse with empirical formulas. Now, it's a very straightforward calculation. For example, if we consider methyl ether as a formula of C2H6O, the mass percentages of carbon, hydrogen, and oxygen can be determined with using 1 mole of methyl ether. So, first of all, we have to figure out the total mass of methyl ether. So, 1 mole of methyl ether is equal to 2 times 12 grams for each of the carbons, 2 carbons, plus 6 times 1 gram per mole for each of the hydrogens, and 16 grams per mole for the oxygen. Then, to get the mass percentage of each element, well, I just divide their mass of each atom by the total mass. So carbon, I had 2 atoms, or 2, in this case, 2 moles of carbon, which is 24 grams, divided by 46 grams for the total, times 100. So it tells me that carbon constitutes 52% of this element, or this molecule. Hydrogen, 6, because it's 6 times 1, divided by 46 gives me 13% as mass composition. Oxygen is the remaining 35. And if you add them all up, should equal 100%. Very important. They are directly related to the molecular formula of the compound, and that's why they're important for us to know and to be able to calculate. So we just take the total mass within that molecule, in this case 2 carbons times 12 grams per mole, divided by the total, 46 grams per mole, gives me my total. Let's try one more example. So I want to know the percent composition of each element in manganese sulfide. So I look at the molar mass and I take this directly from my periodic table. Manganese is 54.94, sulfur 32.07 for a grand total of 87.01 grams per mole. Manganese, well, 54.94 divided by the total gives me 63.14%. So with this one, I can solve the sulfur in one of 2 ways. I can straight up divide the molar mass of sulfur by the total mass, or I can just take 100, subtract the percentage that manganese had, which is 63.14. Either way, I get a percentage of 36.86 for the sulfur content in manganese sulfide. So this is a really good way. It's a quantitative or beginning of a quantitative analysis for chemical compounds. Or if we don't know the molecular formula and we can get some data, we can use this as a step to figure that out.